Good morning. Myself, Dr. Rabindra Jana, Associate Professor of Department of Chemical Engineering, Kolkata Institute of Technology. Today, I will discuss about the topic application of nanomaterial as fire extinguishing agent. As you know, nanomaterial is very small material which is having the dimension within 100 nanometer. So the size of the material is very small, so it is having very high surface area per unit mass. So with a small amount of material, we can cover a large area. That property will be utilized for the fire extinguishing agent. Now for this presentation, we will have an introduction, fire extinguishing mechanism. Then we will discuss about the fire extinguishing agent, whatever available nowadays. We will discuss next nanotechnology, how it will affect the fire extinguishing mechanism, and whatever the current research trend and development, challenges and future directions, conclusion, and finally the references. So today, as you know, the nanometals, it is having extinguishing mechanism, and there are so many of nanometals used nowadays, such as C60, carbon nanotubes, CNT, force reduction, silicon dioxide, aluminum trioxide, zinc oxide, ferrocene, and other so many chemicals, nanomaterials mostly. Here we have shown that mechanism schematically, that is mechanism maybe cooling, starvation, smoothing, maybe intermissions, chemical reaction inhibition, and physical behavior. We'll discuss in details on this mechanism. So, as per that, the information, we know that the fire is an essential element for human civilization. It was initially used for, say, warmth of shelter. Nowadays, it will use maybe say in cooling, cooking, and say for food preparation, tool making and industries, transportation, navigation, agriculture, and land management, social culture significance, and so many things. That fire extinguishing media that we can use, and the fire it is having some hazards, and it is having some risks associated, and even there may be a loss of life due to this fire. There is traditional fire extinguishing agent, but it may have some limitation, such as it may be some having toxicity. Also, it may form a char after the use, and it may come into the water body and soil, so that that may affect our human beings or even aquatic animals. So there is this in search of the materials which is having less toxic and more efficient with relevant to the foresting mechanism. So starvation, it is actually the cut off that the materials or ingredients required for fire incident. As you know, there is the fire triangle, means there are the three requirements for fire incidents, maybe oxygen, fuel, and heat. So if we disconnect that fire from any element, then any of the three elements, then that is called actually starvation. Cooling means for any reaction that it is actually happening at a certain temperature. If we cool down by any means, then the reaction rate will decrease, and if we cool efficiently, so that if we stop, the reaction will stop. So fire incident will be extinguished. And most of the cases we use water so that it will cool down the reaction. And we have seen that in the case of wooden fire, that fire it will be extinguishing if you pour a bucket of water on it. So that is called actually cooling effect. And then next one is a smoothing effect. Smoothing means there is a the covering of the fire so that it will cut off that supply of oxygen most of the cases. And you can see most of the cases we use a cotton or cloth or sack. If there is a fire inside, we cover it so that the oxygen supply to the fire will be disturbed and the fire will extinguish immediately. And there are some chemicals available so that that chemical reaction will be inhibited if we pour that chemicals on the fire. We'll discuss that one, and that is our aim to develop the materials, different chemicals for this chemical reaction inhibition process. Next one is the intermissions, that is the formation of the char, formation of the char and insulin char, so that through that char the oxygen supply will be discarded and heat will not be dissipated, so the fire and incident will be immediately stopped. Next one is a physical barrier. We have that physical barrier means fire door and other curtains, so that it will not spread, or even it will also not supply the air or in terms of say oxygen. Now for different type of fire, actually it is based on the materials available and area shown for fire. For sure, example, there are say mostly five types of fire. One is say that is A, that is solid fire, that is wood, paper, pulp, that part is called actually A type fire. Another is B type, that is flammable material, flammable liquids, gases, and C is the flammable gases. Okay. And D is the metal fire, K is the that kitchen oil fire. So depending on the different types of fire, we have to use the different extinguishing media. As I have discussed, for a type of fire, we use generally water. For B type of fire, we use there are different types of powder, DSP, dichemical powder, and it is mostly ammonium nitrate, ammonium phosphate, or sodium bicarbonate. These are the different types of solid materials used. That is called actually called uh, DCB, dry chemical powder. And for C type, we generally use different type of foam and also carbon dioxide, liquefied carbon dioxide, compressed carbon dioxide. And for D type, for the different special type of fire extinguishing agent, we generally use. For K type also, and can use that foam or that K special chemicals. Now, what are the need for this say advanced fire extinguishing agent? As we know, whatever the traditional method is available nowadays, and fire fighting system is available nowadays, again, it's not so efficient. So our aim is to find the materials or the system which will more effectively extinguish the fire within a few seconds. So the research is going on, and uh, day by day, so many of materials are being developing, and we'll discuss that one in a couple of slides. Now, fire suppression has relied on a limited range of agents, including water, foam, dry chemicals, and gases. Water is effective in cooling and suppression of flames from type A fire, but it is ineffective for the flammable liquids and electrical equipment. Dry chemical agents are effective against a range of fire classes but leave residue that complicate cleanup and harmful to the environment. So new materials are to be introduced. Here we have shown the different type of foam type wet chemical types, water type, powder distributor, and CO2 type extinguisher available in the market. Now, promise of nanotechnology. Nanotechnology is the manipulation of matter on an atomic or molecular scale, and size is within 100 nanometer. So it is having some very unique physical and chemical properties that increase surface area, enhance reactivity, improve thermal stability, which can be harnessed to create innovative fire extinguishing agents. Nanotechnology-based agents are not only more effective at extinguishing fire, but also safer and more environmentally friendly. So nanomaterial can be engineered to enhance the thermal stability or say thermal resistance of the material, reducing flammability, or to create the catalyzing effect, the breakdown of flammable gases, and thereby preventing the fire propagation. Nowadays, so many of nanomaterials are available. Yeah, the research is going on, and people are trying to find that their suitability. For example, say nanoparticles, metal nanoparticles, that is fusion, silver, copper, or manganese, or zinc oxide nanoparticle, magnesium hydroxide nanoparticle. They are combined with melamine cyanurate and phosphorus to create the nanomaterial uh, that reduce its time to take extinguish the fire by about 45.2%. So, day by day, there is the development is going on, and people are now switching to the nanomaterials. Another nanomaterial may be carbon-based nanomaterials, that is graphene, carbon nanotubes, fluorine derivatives that have shown promise in improving the thermal stability and flame retardancy of the material, so that it is more suitable for incorporation in the fire extinguishing material. Another may be say, polymer nanocomposite. The incorporation of nanofiller into the polymer matrix can enhance the mechanical and thermal properties of the resulting material, leading to the improvement of the fire resistance. There have shown different structure of different nanomaterials available. This one is the fluorine, this one is the carbon nanotube, this one is the POs, and this one is the silicon dioxide. There, their morphology is being shown. Now, current research and development will discuss to some extent. There are different hybrid nanometers are used, combining of the nanometals and other uh, metal oxides, maybe in the not in nanometer size. They can also be used in combination. Carbon calcium hydroxide nanoparticle. These nanoparticle can be derived from egg cells and combined with magnesium hydroxide nanoparticle to create a flame retardant properties. Different type of nanoclays may be used also, chloride in phosphorus compound to reduce the peak heat release and delay the ignition temperature. And aluminum nanoparticle, this nanoparticle can be used to create a ceramic barrier that prevents oxygen from reaching the fire and removes excess heat. Zirconium, there is zirconium dioxide. This nanometal is effective at extinguishing fires and inhibiting methane combustion. Now, there are so many also challenges. It is not also free from the toxicity. That nanometals, whatever being used, it is also may have some toxicity, and it may be some environmental effect. The safety and environmental implications of using nanometals must be carefully evaluated. The potential toxicity of certain nanoparticles raises concern about their long-term effective use on human health and ecosystem. Regular framework. The development of regulatory standards, guidelines for the use of nanometals in fire suppression is essential to ensure their safe and effective applications. Scalability and cost. The production of nanometal can be complex and maybe it is complex, costly nowadays. But with the advance of technology and the modern instrumentation facilities, the cost may be reduced drastically. So the future scope of using of nanometal in this area is very high. Long-term stability. The stability of nanometal in various environments, including extreme temperature and chemical exposure, must be assessed to ensure their reliability as fire extinguishing agent. So, for the conclusion, we may say that the development of nanomaterials for fire extinguishing marks a transformative step in firefighting technology, offering solutions that are more efficient, effective, and environmentally responsible than the traditional method. Nanomaterials is having high surface area, so it may have also have a high thermal stability and to enable reactivity that enable rapid heat dissipation, oxygen isolation, and combustion interruption. Despite of the impressive progress, challenges remain, particularly in managing the environmental and health impacts of certain nanomaterials, nanopowders, which requires careful formulations to prevent the toxicity. So, future research work will help us for optimizing the materials for specific fire types, exploring their safer alternatives, and improving the accessibility and cost effectiveness of nanomaterial based extinguishing agent. Now, for this, we may go through these references. Thank you.